Hello, and welcome to my not-so-comprehensive guide to building an extremely hot metal melting forge. Electric power is easy to control and cheap, so the forge will not be powered by anything but the best. No propane in sight. Although there are many ways to convert electricity to heat, for our choice of heating element, we will look to the humble toaster. Inside of the bowels of the toasting beast lie rows of nichrome wire heating elements, and because I have ruined all of my other toasters, we will be using commercial nichrome wire in this not-so-comprehensive guide. The first step in this is to find out the limitations of 32 gauge wire using my handy-dandy testing rig. The tests will start with various amounts of injected wattage in order to find the sweet spot between safe and melting wire and overheating power supplies. All tests will be conducted first with approximately 2 inches of wire, and then they will be gradually increased. So this is the first video. It is conducted with a 20-watt power supply, and as you can see, the nichrome wire in about a 2-inch length is very easily cut through, and you can even see a bit of a spark. It's a very energetic reaction. Although this is no doubt getting very hot, it is not quite the result that we would like to see in making a forge. On to clip 2. Clip 2 is a very quick clip. It's just to note that with a longer amount of nichrome wire, there is more resistance, and therefore the 20 watts can be dispersed as heat better. So if you have enough wire, then you can compensate for the high wattage. However, this 20-watt power supply probably is the limit of the nichrome wire, and therefore let's go to a higher wattage. So now I conducted the previously conducted test on a 48-watt power supply. This meant that a lot more amperage was going through the nichrome wire, and therefore even with a longer starting length, the nichrome wire was able to break to pieces and almost short out the power supply. Also very similar to before, when I added more wire, the resistance therefore went up, meaning that you could stably have this length of nichrome wire, which is an adequate length to make a small forge, in your possession without destroying a power supply or breaking the wire. As a test to see what this wire could do, I firstly conducted a test to see if this dinky little 32 gauge coil of wire could melt solder, and it was able to melt solder. Holding the solder on there for like 15 seconds, it was able to create little balls of solder that melted off, and in some cases even cut straight through the solder, but in these instances the solder would just reform when I got to the other side. The last test that I've conducted thus far was to test the burning powers of this nichrome wire. So I took a piece of paper and experimented to see if it could cut through the paper. The results were very conclusive and showed that a 48-watt power supply could supply adequate wattage and adequate current through the nichrome wire, dissipated as heat, to burn paper and put it on fire, meaning that even with such a small gauge, we are ready to go on to the next step, which will be in the next video, completing the structure of our foundry and making it so that we can legitimately melt some metal. This has been part 1 of the trilogy on melting metals. Thank you for watching.